Yes. So, good afternoon, everyone. Welcome back to our YouTube channel, EREIS. So, we have discussed something about the electrochemistry. So, in two lectures, this is the third lecture regarding the electrochemistry lecture. So, today's class we will discuss about the relationship between the electrode potential E and the Gibbs energy G and as well as equilibrium constant K. So the relationship between these three we will explain. And as also we will study the Nernst equation. Okay, so we will study all these things. Yeah. See the relationship between the free energy and cell potential. So see this one delta G naught. Delta G indicates the free energy. Okay, delta indicates the change, whatever the delta H, delta G, whatever the delta indicates this one. Delta indicates the change and G indicates the free energy. Actually, G is a one term, free energy term that belongs to the actually thermodynamics. Okay, one reaction is either spontaneous or can be explained by using the delta G value. If delta G is equal to negative, that is spontaneous reaction. That is finally what is that one? Delta G is a thermodynamic term. The relationship between the delta G, that is free energy as well as cell potential E naught, can be discussed now. So delta G is equal to minus NFE. So that is the relation. Actually, here not indicates the what is that one standard condition. In previous class, we have discussed that. This not indicates the standard condition. That means that is measured at the standard condition value. Whatever, if it is solution, that is 1 molar concentration. If it is gas, that is 1 atmospheric pressure. So delta G naught. So standard free energy and the relationship between the standard free energy and E naught. That means cell potential, standard cell potential value. This one. If you take so normal values delta G is equal to minus NFE. If you take standard value of the both two, delta G naught equal to minus NF E naught. This is the relationship between the free energy as well as cell potential. Okay. So this equation is a bridge equation between the this thermodynamics as well as electrochemistry. This term belongs to the electrochemistry and delta G belongs to the thermodynamics. Okay, so these two are the so this is the bridge equation between the whatever the free energy as well as cell potential. This one, yeah. Here, what is N? N indicates the number of electrons in a chemical reaction. For example, A gives A plus electron is there. Then here one electron losing. So that is why number of electrons involved in a chemical reaction that can consider as a N, small n. What is F? F is a Faraday constant. F. Okay, this is a fixed value. What is the value? 96,485 coulomb per mole. So this is the value. So generally, while calculating some numerical problems, you will take as a rough value. What is that one? 96,500 coulombs also. But what is the correct value? Means exact value is 96,485 coulomb. That is the this Faraday's value. If anything is given, if we know one value in these two, whatever the delta G and E value, if we know one value in a chemical reaction, then automatically we can calculate the other value also easily by using this relation delta G is equal to NFE or delta G naught equal to minus NFE naught. So by using this equation. See, this is one problem, numerical problem regarding the relationship between the delta G and E. Okay, see, what is the problem is given the standard EMF of a Daniel cell is 1.1 volts. That means here he mentioned standard EMF. EMF is nothing but E cell value is given that E naught value equal to how much is given? 1.1 volts is given. Okay, this much of value is given. E naught cell value is given. What is asking? Calculate the standard Gibbs energy of that cell reaction concerned cell reaction. Okay, E naught value is given and asking what is the standard Gibbs free energy. This one, okay, is given E naught value and asking delta G naught value. So what is the formula? This one, delta G naught equal to minus NFE. Just write that formula. Delta G naught equal to minus NFE naught. So in the what is the reaction is given? What is the reaction? Zinc solid plus copper 2 plus aqua solution it gives. What is this one? zinc 2 plus copper. Okay, zinc here losing 2 electrons, and what is happening? Copper gaining 2 electrons. That's why. So what is the n value? Number of electrons charged or number of electrons involved in this reaction is losing 2 electrons and gaining 2 electrons. That's why n value n equal to 2. We have to take n equal to 2. Delta G naught equal to minus NF E naught. We have to substitute all these values. N, F, E naught. Okay, then we can calculate the delta G naught simply. So here, how much value n equal to 2? Then Faraday, it is a fixed. That means it is a constant. We already know 96,487 coulombs per mole. This is the value of Faraday constant. And E naught value also given. What is the value? 1.1 volts. See this one, 1.1 volts is given. Then therefore, delta G naught equal to, we have to substitute these three values, minus NF E naught. What is the N value? N equal to 2. And F value, what is our F value? 96,487 coulombs. Then we have to substitute E naught value, 1.1. So by solving these three, what will minus 21,227 joule per mole. We convert joule to kilojoule, it will be converted into 212.27 kilojoule per mole. Okay, if I ask it in the joules, it is enough 21,227. If it is converted into kilojoule, 212.27 kilojoule per mole. This is the way of calculation of the delta G naught value, free energy value. Okay, this is the relation. If he is given delta G naught value and chemical reaction is given, he will give chemical reaction also. By using the chemical reaction, we have to observe the what is the n value, okay, based on the number of electrons involved, and he will give the delta G naught. That means Gibbs free energy, standard Gibbs free energy will mention. Then also we can calculate the whatever that one E naught value also. E naught equal to minus delta G naught by NF. From that equation we can also calculate the E naught value if free energy is given. Okay, so this is the interrelationship between the delta G naught as well as E naught. Next, see this one. So this one, whatever we have discussed this one, delta G naught equal to, delta G equal to minus RTK. This one, delta G naught equal to minus NF E naught cell. So we have discussed this one. So delta G naught equal to minus RT ln K. This is the one equation. And another equation is actually delta G is equal to minus N E naught. So by equating these two, what will be happening? Delta G naught equal to minus RT ln K minus NF E naught. Okay. In a single equation, I am writing delta G naught equal to minus RT ln K and minus NF E naught. We have seen this one already. This is new equation actually. Delta G is equal to minus RT ln K. K is a equilibrium constant here, K. And R is a constant. And T also, here T is resembles that it is a temperature. Okay, yeah. So from these two, whatever the minus NFE and RT. Now we are doing the relationship between, we are seeing the relationship between the E naught cell value and equilibrium constant K value. Already we discussed about the interrelation between the delta G and E naught. Now we will see the relationship between the electrode potential and equilibrium constant K. So from these one, okay, whatever the minus RT ln K equal to minus NFE. Here minus will be get cancelled here, minus NF. So minus get cancelled. Now we have to calculate the E naught value. Then E naught equal to minus RT here. Divide, it will be divided here. Why? Because here multiply, it will be divided. So minus here minus get cancelled. Plus RT by NF ln K. Okay, right. Next, this equation is the equilibrium. Okay, this is the standard equation. Okay, it's enough. If it is given, okay, if it is in equilibrium state, okay, other than the equilibrium state, this is the equation is enough. If it is at equilibrium state, what will be happen? So K delta G naught equal to 0. That means we have to substitute the whatever the T and F value or T F value. We have to substitute these three values. Why? Because these are the constant at the standard conditions. What are the values we have to substitute? R equal to, based on the whatever the units here, we are substituting R equal to 0.0821 liter atmosphere Kelvin. Okay, what is that one? R value. T we are measuring at the standard conditions. That's why it is at room temperature. What is the value? Room temperature is 25 degrees centigrade. Okay, that is also 25 degrees centigrade means how much? 298 Kelvin. And Faraday, we know the constant. This constant we know. What is how much value? 96,495. That means 96,000 is roughly 500 Kelvin. So substituting these three R, T, and F, what will, and also see this one ln k equal to ln x equal to 2.303 log x. Conversion of the ln to log means we have to multiply the 2.303 ln equal to 2.303 log x. This is a mathematical equation. Okay, right. So ln x equal to 2.303 log x. So now we can substitute L equal to 303 log a. All this by simplifying what do we E naught to 0.092 and log. Sir, make me host. Yeah, see this one. So this is a relationship between the E naught and K value. That means equilibrium constant and that value. Okay, now we will discuss about the Nernst equation. Okay, yeah. So what is Nernst equation? It explains the relationship between the, okay, what is that one? Electrode potential E value and concentration of the ions. Okay, that is explained by the Nernst. So that equation is called as Nernst equation, the interrelation between the electrode potential and concentration of the cell. We can also mention the temperature also in this. Okay, so the relation is called as Nernst equation. So how to derive the Nernst equation? From the thermodynamic equation, delta G is equal to delta G naught plus RT ln Q. Okay, Q is nothing but equilibrium constant. Okay, right. So delta G is equal to delta G naught plus RT ln Q. So we know already that delta G is equal to minus NFE. In previous slide, we see that one. So relationship between the delta G and E, delta G is equal to minus NFE. I am substituting the value of delta G here. Delta G is equal to minus NFE. Here delta G naught is equal to minus NFE naught. RT ln Q same. So then I am multiplying this equation. For example, this is equation 1, this is equation 2. This second equation I am multiplying with the, sorry, I am dividing total equation with the minus NF. Okay, this second equation I am dividing with the minus NF. So total minus NF, minus NF, minus NF get cancelled. Here minus NF get cancelled. So E cell or E equal to E naught minus RT. Here we are dividing with the minus NF. That's why minus NF ln Q. Okay. Similarly, in previous slide, what we have substituted this well, RTF and ln. All these values substituting, what will be happen? So 0.0592 by n. Okay. So from this one, it will become 0.059 by n. So ln will be converted into log Q. So this is the Nernst equation. It gives the relationship between the electrode potential and Q. Okay. Q or K. So what is Q or K? This is a equilibrium constant. Okay, yeah. So this is a Nernst equation. E cell equal to E naught cell minus 0.059 by 2 n log Q. Here E cell electrode potential and E naught indicates the standard electrode potential. N indicates the number of electrons involved in that corresponding chemical equation, and Q, here Q indicates the equilibrium constant. What is equilibrium constant? Concentration in a chemical reaction, if A plus B, in a chemical reaction A plus B power plus 2 gives A plus 2 plus B is there. Then what is the chemical equilibrium? Q equal to concentration product of concentration products by, so product of reactants concentrations. Okay, like that. Yeah. So one more numerical problem. What is that problem? Starting from the standard. So one equation is given. What is that equation? Zinc 2 plus. This is solved with copper 2 plus copper. That means it is undergoing oxidation. This is undergoing reduction. Oxidation of cell is given. Reduction of cell. This is complete cell reaction. Voltaic cell reaction is given. Calculate the E cell value. That means cell potential value when copper 2 plus this one. So two values are given. He is asking the final value simply. So what is the value? Actually seen this type of question in yesterday's class. So what is that given? Two electrode potential are given. We have to calculate the final cell potential value. Okay, here copper 2 plus 2 copper. E cell value E naught of cathode is given. What is the value? 0.34 volts. And E naught of what is that one? Anode value is given. What is that value? 0.76 volts. Already we seen that. So E cell equal to E cathode minus E anode. So E cathode value how much? 0.30 volts minus of minus 0.76 volts. Here 1.10 volts will become. Yeah. So another problem. This is regarding especially about the Nernst equation. Okay, right. So what is the problem? You have to see, observe here. Cell reaction is given. What is the cell reaction is given? Magnesium reacting with the silver. So magnesium plus 2 moles of the Ag. Okay, this is a solid form. This is aqueous form. So that's why he mentioned in bracket S. S indicate the solid. Okay, magnesium plus it is reacting with the 2 moles of the Ag plus. Then what will be formed here? Mg2 plus 2 Ag. Okay, magnesium plus 2 Ag plus gives magnesium plus 2 Ag. So this is a one chemical reaction is given. So what he is asking, calculate the E cell value. Okay, he is given one chemical reaction. Along with the chemical reaction, he mentioned the concentration values here. This one and this one, concentrated values he will mention. And also he mentioned that E naught value 3.17 volts is given. Then what is asking? Calculate the E cell value. Okay, yeah. So this is regarding the Nernst equation problem, right? See this one. So we have to we can calculate the E cell value by using the Nernst equation. What is the equation? E cell equal to E naught cell minus RT by NF ln concentration of products divided by concentration of reactants. In previous one we have seen this one. Here Q indicates the concentration of the product divided by concentration of the reactant here. Actually here we taken that standard conditions. That's why we have substituted all these R, T, F value. That's why this value came. But in question he is not given the standard conditions. That's why we should whatever the apply all these value. We substitute the all these value. So see this one. Yeah. So E naught cell is given. So we have to substitute E naught cell value in this. E cell equal to E naught cell. E naught cell value how much? 3.17 volts. So I substituted here 3.17 minus. So RT by F value is fixed. That means this is constant. Why? Because this is also standard condition. So 0.05 nanovolts by here N indicates the number of electrons involved in a chemical reaction. How much electrons are involving? Magnesium is converting into magnesium 2 plus. That means magnesium losing the 2 electrons. Meanwhile, silver plus here Ag plus 1 is there. It is multiplying with the 2. That means it is gaining 2 electrons. Okay. So completely in this reaction 2 electrons are involving. That's why we are N equal to 2. Then log. So concentration of product. Here product is what? So we should consider the only aqueous solutions. Okay. For the pure solids, activity or concentration equal to 1. For magnesium solid equal to 1 as well as silver solid equal to 1. That means unity. So we need not to take here. What is that one? Ag divided by magnesium. Why? Because here 1, 1. Okay. So we need not to take silver as well as magnesium. So what is the product here? Magnesium 2 plus is present. So what is the concentration of given? 0.13 volts is given. I am substituting this one. And So divided by Ag plus whatever the coefficient is there, we have to square. We have to take whatever the superscript like this. Here 2 is present, that's the superscript 2. 3 is there, cube like this. So 2 is there, square, 2 square, Ag plus square. Then I am substituting the Ag value. Ag value how much? 0.0001 volts, this one. And we can write 0.001. How to simplify this one? 0.1234. 4 values are there. That's why 10 power minus 4 we can write. If 0.01 is there, after 0.01 means 2 digits are there. Then what we can write? 10 power minus 2 like that. Here after 1, 2, 3, 4 digits are there. That's why 10 power minus 4 whole square. That means 10 power minus 8 will become. Okay. Here roughly we can take 0.06 divided by 2. That means 0.03. Then simplifying all these value, log 0.13 divided by 10 power minus 8. So what is the value will become? 0.21 volts. So by subtracting from the 3.17 to 0.21 volts, 2.96 volts will become. Okay, that is the E cell value. So this is regarding the Nernst equation. Next, relationship between the delta G naught and E naught and K. Okay, yeah. So what is the relationship, and if any chemical reaction, is it spontaneous or not, can be determined by using this reaction. In first class and second class we discussed that zinc rod dipped in the copper sulfate solution, it will be dissolved in the copper sulfate solution. Why it is dissolving? Based on the E naught cell value it is dissolving. In this slide we will discuss about that one. Okay, see interrelationship between the delta G naught, E naught and K. So before that you see, so if E naught cell value is, okay, E naught cell value is greater than 0. See this column, E naught cell value is greater than 0, then that reaction is called as spontaneous reaction. At that time 1.10 volts will become, okay, total cell potential of zinc and copper 2 plus. That reaction how much? 1.10 volts. Okay, this one, see, yeah, this one, this value how much? 1.10 volts. That's why spontaneously zinc rod will be dissolved in the copper sulfate solution. Okay, here this one. Okay, like see this one. Yeah. So E naught cell value is greater than 0, then that reaction is spontaneous. E naught cell is less than 0, then the reaction is non-spontaneous. Okay, simply it is greater than 0, spontaneous. Less than 0, that means if the E cell value is negative value, that is called as non-spontaneous reaction. Okay. Yeah. So next one, what is a non-spontaneous reaction example? If you take zinc sulfate solution and keep the copper rod, it does not dissolve. That is an example for the non-spontaneous reaction. Okay. Yeah. So less than 0 value, negative value will become E cell value. And if E cell equal to 0, that is at the equilibrium. So this is a thermodynamic term, delta G, free energy. So if free energy less than 0, that means if delta G is negative value, that is called as spontaneous reaction. If it is greater than 0, that means if delta G is a positive value, that is non-spontaneous reaction. So you have to observe completely opposite to the E cell value. Okay, if delta G is positive, okay, delta G is positive, what is that one? Non-spontaneous. If E cell is positive, that is spontaneous reaction. That's why delta G is equal to minus NFE. See this equation. So delta G is equal to minus NFE. If it is positive, so here what will be a negative term is there. That's why E naught cell is negative. So if delta G naught is positive, this is negative. So that's why total both are non-spontaneous reactions. If delta G is negative, already negative is present, negative. So then E cell is positive. That's why whatever the final conclusion, delta G naught is negative, that is spontaneous reaction, and E cell is positive, that is spontaneous reaction. Okay, right. So what is the interrelationship between this one? This is the equation. Delta G naught equal to minus NF E naught cell. So then relationship between the delta G and K. So delta G equal to minus RT ln K. This is the one of equation we have discussed previously. So delta G naught equal to minus RT ln K. K is a equilibrium constant. Then relationship between this E cell value and K. So we discussed it in the where Nernst equation, E cell equal to minus, so RT NF ln K. So this is already discussed. E cell equal to E naught cell minus RT by NF log K equilibrium. That is the Nernst equation. So this is a relationship between these three terms. What are those terms? Delta E naught and E cell value and K equilibrium constant. Okay, note down this one. All this table important. So whether the reaction is spontaneous or not, he will give the whatever the terms. So he will give some value delta G naught equal to plus 2.30 and E cell value equal to 0.01 volts, like that he will give some values. So he will ask the which of the following reaction is spontaneous. So 1, 2, 3, 4 options will be give. Then we have to check. So in which of the option delta G is negative and E cell is positive, like that we have to check and choose the correct answer. And also we can explain the spontaneity of a reaction based on the K also. Okay, if K is greater than 1, what is that one? Spontaneous reaction. So in these two conditions, we are taking 0 as a standard one. But in the, what is that one? Equilibrium constant, we have to take 1 as a standard condition. Here 1. K is greater than 1, that is spontaneous, and less than 1, non-spontaneous reaction. Okay, yeah. So today's class, we have discussed all these things. Okay, we will discuss some more thing about the conductance. Okay, right. See this one, conductance. What is conductance? Actually, the conducting power of all the ions present in the electrolytic solution, that is called as conductance. Okay, yeah. So what is the mathematical representation of a conductance? C is equal to 1 by R. This is a mathematical equation to conductance. So conductance can be represented with the C, capital C. So C equal to 1 by R. So what is R here? R is a resistance. Okay, the reciprocal of resistance is called as a conductance simply. So C equal to 1 by R. So 1 by R means, so the reciprocal of resistance is called as conductance. So what are the units for the conductance? Siemann. Siemann is nothing but ohm inverse. The units for the resistance is ohms. Okay, actually resistance capital R. Resistance represented with the capital R. And what are the units for the resistance? Ohms. So what are the units for the conductance? Conductance equal to 1 by resistance. So 1 by ohms, that is ohm inverse. Okay, ohm inverse, or also we can say mho, mho, mho. Ohm inverse and mho both are same, or simply we can say Siemann. 1 Siemann equal to 1 ohm inverse. That means Siemann equal to ohm inverse, or mho, all are same. Okay, these are the units for the conductance. Okay, yeah. So what is the specific conductance or conductivity? Okay, yeah. So this is the relationship between the specific conductance as well as conductance. K equal to specific conductance and C is a conductance and X is a cell constant. What is cell constant? Cell constant X equal to L by A. Okay, L by A, that is a relation. So K equal to C into X. This is a relationship between the specific conductance and this is cell constant. Cell constant X equal to L by A. And next then molar conductivity lambda m. So what is molar conductivity? Conducting power of all the ions produced by dissolving 1 mole of electrolyte. Okay, that is called as molar conductivity. We are taking here molar. That's why we have to take 1 mole of the electrolytes. Okay, 1 mole of the substance which has to be dissolved in the electrolytic solution. So all those ions will be generated by dissolving 1 mole of the substance. Some ions will be generated. So conducting power of all those ions is called as molar conductivity lambda m. Okay, molar conductance lambda m. So what is the mathematical equation for the lambda m? Lambda m equal to K into V. See this one, lambda m equal to K into V. This is into K into V. That means multiplication of specific conductance into volume. Okay, yeah. So volume into specific conductance equal to molar conductance, molar conductivity or conductance, lambda m equal to K into V. So lambda m equal to, we can substitute the V equal to 1000 by C. Okay, yeah. So what are the units for the lambda m? Ohm inverse, centimeter square, mole inverse. Important these units so many times also. So what are the units for the lambda m inverse? Lambda m equal to molar conductance equal to ohm inverse, centimeter square, mole inverse, or ohm inverse we can say Schumann, centimeter square, mole inverse. This is the unit for the molar conductance. Next, equivalent conductance. What is equivalent conductance? The equivalent conductance means if you take, so conducting power of one equivalent of electrolyte, if you take one equivalent of, so any substance by dissolving in the electrolytes, so some ions will be generated. The conducting power of one equivalent substance, that is called as equivalent conductivity. Okay, yeah. So equivalent conductivity means, so see the difference here. Molar conductivity means one mole of the substance has to be dissolved. Here equivalent conductivity means we have to take one equivalent. Okay, so equivalent equal to molecular weight divided by valency or number of electrons transferred in a chemical reaction. So it will become in the solutions chapter especially. Okay, in the while expressing the concentration of the solution, we use normality equal to, so equivalent weight will become, so based on that one equivalent. Okay, equivalent weight equal to molecular weight divided by number of electrons involved in a chemical reaction or acidity or basicity, like that we have to take equivalent. So number of one equivalent substance is dissolved in the electrolyte, the ions will be generated. The conducting power of those ions is called as equivalent conductivity. So lambda equivalent equal to K into V here. So what we have to substitute V value here, 1000 divided by N. Previously see this one, C means molarity. Okay, here we should take normality only, not molarity. M equal to N by Z, the relationship between the molarity and normality. M, molarity equal to normality divided by Z. Z means number of electrons involved in a chemical reaction, or if it is acid, basicity, if it is base, acidity, like that. Okay, M equal to N by Z, or N equal to M into Z. Okay, by using N we can calculate the M, or interrelated, whatever the vice versa, we can calculate the molarity also. Okay, so what are the units for the equivalent conductance? Ohm inverse, centimeter square, gram equivalent inverse. This is only the difference between the molar conductance and the equivalent conductance. Previously ohm inverse, centimeter square, mole inverse. Okay, but in this case what is that one? Ohm inverse, centimeter square, gram equivalent inverse. These are the units for the equivalent conductance. Yeah, see this one numerical problem regarding this one. The specific conductance of 1 mole, okay, solution is given 0.26 Siemens centimeter inverse. Some H2SO4 is given, 1 molarity concentration is given. The specific conductance K is mentioned here. See this one, K mentioned 0.26 Siemens centimeter inverse. Then is asking find out the molar and equivalent conductances of the solution, corresponding solution. H2SO4 is given. We have to calculate the molar conductance as well as equivalent conductance. Right. So these four options is given. First of all, see what is the mathematical equation for the molar conductance. So K into 1000 by V, sorry, K into V or K into 1000 by molarity. So I'm substituting 1000 into K by molarity. So 1000 into what is specific conductance is given. So in this one, K is a specific conductance. Here also given specific conductance is given that 0.26 divided by 1.0. Why? Because here 1 molar H2SO4 is given. So that's why. So 1000 into 0.26. That means 260 divided by 1. How much? 260. Siemens centimeter square mole inverse. Why? Because this is molar conductance. Okay, right. Now we have to calculate the second one, equivalent conductance. What is the formula? Equivalent conductance, lambda equivalent equal to K by N into 1000. That means 1000 into K by normality. Here molarity, here normality. So 1000 into 0.26. Here specific conductance is given 0.26 divided by normality. How much normality is given? So actually it is not given. He is given that molarity 1 molar another. Then we have to convert into normality. Already I explained that normality equal to molarity into Z. Okay, so Z here acid is given. So H2SO4 is a acid. The basicity of the H2SO4 is 2. Why? Because H2SO4 sulfuric acid can give the 2 protons. Okay, that's why the basicity of this acid is 2. So m equal to n by z or n equal to m into z. So now we have to calculate the normality. Normality equal to molarity into whatever the acid is given. That's why basicity of this sulfuric acid. So what is molarity? 1 into what is the basicity of sulfuric acid? 2. So 1 into 2. So that's why normality equal to 2. So that 2 we have to substitute here. So normality 1000 into 0.26 divided by 2. How much value? So 130 Siemen centimeter square equivalent inverse. So here, how much molarity? 260, and what is normality? 130. So this one. So based on this, we can calculate the molar conductance. Okay, if we give the molar conductance of the substance, he will also ask the specific conductance. So this is the interrelationship between the molar conductance as well as specific conductance equation. Okay, if you give, he has given that molar conductance K, we can also find out the K also. Why? Because here molar conductance into molarity divided by 1000 equal to specific conductance. Okay, like that we can calculate the numerical. So in this, whatever the resistance, conductance, molar conductance, and cell constant actually I am not given the problem, but that is also important here. Cell constant here, this is also important. Cell constant equal to L by A. Okay, L is length and A is a area of cross section. So what are the units? Length in centimeters divided by what is the units for the area of cross section? Centimeter square. So centimeter divided by centimeter square means centimeter inverse. Okay, that is the unit for the cell constant x equal to centimeter divided by centimeter square. That means length divided by area of cross section. So centimeter inverse is the unit for the this one. So this is also very important while numerical calculating the numerical. That means the relationship between the specific conductance and the cell constant. He will give the length as well as area of cross section and specific conductance. He will ask the how to find out the what is that one? Conductance value. Otherwise we will give the conductance as well as this one cell constant value, length as well as area of cross section. Then we have to find out the K value. K equal to whatever the given conductance value as well as cell constant value, whatever the length divided by area of cross section. This is also important for the numerical problems. You have to do in textbook so many some problems are there. You have to do that one. What is that one? Relationship between the K and C. Okay, K equal to C into X. So conductance, resistance, specific resistance, molar conductance, equivalent conductance. These all are important for the numerical calculation. Okay, I given only one numerical, but these are more important. Okay, this is simple. Lambda equal to K into 1000 by N. Here lambda equal to K into 1000 by C. Here C is a molarity, molar conductance. That's why molarity. Okay, this one conductance.
Yes, sir.
Here also, sir. Okay, this is the conclusion. What is the conclusion? So we have discussed here this class 3 terms, especially what are the terms? Yeah, so relationship between the electrode potential E cell and delta G and equilibrium constant K and Nernst equation. What is the Nernst equation? We have discussed, and also we discussed that. So what are the conductance, resistance, specific resistance, equivalent resistance, and molar resistance? So all these are we discussed. Please focus on the numerical problems of the Nernst equation as well as conductance, molar conductance, equivalent conductance. These are important for the numerical problems. Okay, thank you one and all.